All right. Chapter 5, Section 6. We're skipping Section 5. Why are we skipping Section 5? It's proofs. Nope. You haven't done anything all day anyway. Might as well get something done now. Okay. We have a triangle. None of the three sides of that triangle are congruent. Means they're all different lengths. The way to be able to determine what the largest angles are, the largest angle is always going to be opposite the largest side. So I've got 9 as my largest side here. I know that angle C is my largest angle. What would be my second largest angle? A, because opposite that, Amber, is 8, which is the second largest side. And then obviously 6, which is the smallest side, would include the smallest angle. All right? All three of them add up to how much? 180 degrees. All right? So if we were going to take a look at a triangle that did not have equal sides, and we were given an angle on there, we'd be able to help figure it out, right? All right. Oh. On a right triangle. A right triangle has one angle of how many degrees? 90 degrees. So we know that. If we're given a second angle on it, we should be able to figure out what the third angle is. Pretty easy, right? Right triangles? All right. One is going to ask you, draw 3 triangles, one obtuse, one acute, and one right. What's an obtuse? What's an acute? What's a right? What kind of triangle is that one? Acute. Why would it be an acute triangle? All angles are less than 90 degrees. All right? So if I had a triangle like this, obtuse, because we'd have an angle here that would be greater than 90. All right, this is greater than 90. This is less than 90. So a right triangle has one angle that is 90 degrees. All right, that's a right. So it asks you here, draw 3 triangles, one obtuse, one acute, one right. Label the vertices. Identify the longest and shortest sides of the triangle. So label it A, B, C, D, and identify, always when you do a triangle, your angles get the large or the capital letters. Opposite that letter is going to be your smaller letters, your lowercase. Notice the B, A, and C. So that's how you label your triangles. You want to be able to find the longest and shortest sides of the triangle, identify the largest and smallest angles, and describe the relationship between the longest and shorter sides and the longer and shorter angles. All right? On the assignment, same thing. Which are the largest and smallest angles of each triangle? Should be easy to tell, right? And then the last one is, you need to figure out the missing angle. All of them. Now let's take a look at the second page. Always. Good. For any triangle, the sum of lengths of any 2 sides is greater than the length of the third side. What does that say? The sum of lengths of any 2 sides is greater than the length of the third side. For any triangle. This is called the triangle inequality theorem. It's a theorem you'll need to remember. Triangle inequality theorem. Use that to figure out let's see, we got problems. You've got 8, 9, 10, 11, and 12. All right? You want to go through examples of this? Can a triangle have side lengths of 22, 23, or 33 and 25? Can they? How would you figure it out? Add two lengths together. Is it greater than the third? Take two other lengths. Is it greater than the third? Take two other lengths. Is it greater than the third? Remember the triangle inequality theorem. What they've done here is I have triangle lengths of 22, 33, and 25. So I added 22 and 33 together. Is it greater than the third? 22 and 25 together. Is it greater than the third? 25 and 33, is it greater? If all lengths are greater than a third, then yes, this can be a triangle. If you come up with something that you add two lengths together and the third angle is larger, then no, it can't be a triangle. Okay? Here's an example, 3, 7, 11. Is 3 plus 7 greater than 11? No, it's less than. This right here eliminates those lengths from being a triangle. All right. You guys should be able to figure out 8, 9, 10, 11, and 12.